Hi guys. Also, let me know if you can hear my voice. We'll start very shortly in 1 or 2 more minutes. And as I have written, I am aware that the mocks have started and some people have started appearing for them. Some people are still deciding which one to take and so on. So if you have any question regarding anything, feel free to ask. We can spend 4 5 minutes discussing that also before we start with the class and course. Also, apologies, we had to move this. We generally take this on Sunday evening because I felt that was the best time. Most people are at home and they can spend an hour. But for some reasons, we couldn't take it yesterday, so I have moved it to Monday. So thanks for attending. I'm aware that a lot of you work and it's a bit difficult to do things on Monday when the entire week's work is in front of you. But we'll see. What we plan to cover today is average and mixtures, uh, mostly basic stuff. So if some of you already know a lot of it, it might not be as valuable. It might be a good revision, but we'll have to see. But we'll cover some of the basics and we'll go through some questions to see how we can do that. So just 1 more minute and then we'll get started. Please post something just to let me know that you can hear my voice because I haven't seen a single post, so I'm getting a bit concerned. Just write hi or something like that. Okay. Okay. If there is a lot of additional noise, I'm not sure. I think the setting I have kept is same as earlier. If it gets very bad, let me know. And the comment section also for Facebook works separately each time I go live. So today I can't see the comments very easily, but I can see them with some delay. So Uh, Sai is saying Sunday it would be better if it will be on Saturday. Sunday is mock day, which is fine. Do you guys give the mock also at the evening time, as in if you give it at 10 p.m. or something like that? Or are they scheduled? I'm not very aware how exactly it works. Do they schedule a certain time? In which case I can move it to accommodate the mocks. But Saturdays, if you have to give mocks on Sunday, I think you should. Maybe not take class on Saturday also and focus more on preparing yourself for the mocks. Uh, but we'll see. We can change the time to Saturday or Friday, whatever suits most people, and keep letting me know whatever is most suitable for you, and we'll work accordingly. So that's not a big problem. Uh, so I'll get started with the topic for today. Uh, so averages. So this is the agenda. I've just kept it here in small to remind me. So let's get quickly started. The topic is relatively easy. If you get a question on average, you should get it right. You should not be missing these marks. There is very difficult to. It's very difficult to create a very difficult question using averages. The only difficulty you can add is in calculating, etc. So let's see what what exactly average is. We'll start completely from the basics. So if in a class just give me a second. If in a class there are 5 students and each of them have different weights, let's say this is the weight of each student in the class, so the average of these 5 students would just be the sum divided by the number of occurrences. I think this is like way back seventh standard you study this, so I won't spend a lot of time on it. If you have doubts regarding the very basic stuff, go to the platform and you can see very standard videos. But here this would have been 60 plus 72 plus da, 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 divided by 5, and that would be the average. So that's how you can calculate the average. Now, doing it this way might take you a lot more time. So people have devised, and it's very obvious to come up with shorter methods also to do this thing. and we'll see them very shortly. First, let us see one or two very basic questions to get a better feel of averages. So let's say in a class there are 10 students and their average weight is 60. So 10 students and they have an average weight of 60 kgs. And then one new student joins and his weight is 80 kgs. So what would the average be? So one way you can do, which most of you know, is you can just multiply to calculate the total weight in the class, which is 60 into 2, 10 plus 80 into 1, divided by the total number of students, which is 10 plus 1, 11, right? And that will get you the answer. This will take a bit of time. The other way, which is shorter, is you know that 60 is the average. So for the 11th student also, if he had been a 60 kgs, the average would have stayed at 60. So the additional weight that he's bringing is 20 kgs. So you can do it by taking the average of 60 plus the additional weight of 20 divided by 11. So the additional weight gets distributed among 11 people and you get the final answer. And this will be 60 plus 20 into 0.909 and whatever, you can do the math. I think it will 1.818. So it will be 61.818. So this is the new average. So what you're doing is you're just taking the earlier average and checking whatever is the deviation from that and using that to calculate the new average. For example, in the same question that we have over here, you have, say if this was the set and you had to calculate the average, you can just assume 60 as the average. So let's assume we assume 60 as the previous average. And then we have this at 60, this at 60, this is plus 12 and this is plus 24. So this is plus 36. And then this is minus 12. So plus 36 minus 12, overall it becomes plus 24. So plus 24 divided by 5. Because there is 24 deviation of 24 and it's distributed across 5 members. So your actual average will be 60 plus 24 by 5 or 64.8. So this is actually a shorter way than adding all of them and then dividing by 5. So that way it's a bit helpful. Most of you intuitively would also be doing it this way, but if you are not, you should know. There's nothing very magical in here. Let me know if you find it, if you are following or if you're not following. I'll assume that this stuff is fairly simple. So if you're not following, just spend a time on some of the videos on the platform and you should be able to follow very easily. Now, the other thing which also might be useful to know is what is mean, median and mode. So when you say average, it's the same as mean. So average or mean are interchangeable. It's the same thing. What exactly is median? Median is for what number divides the data set into two equal halves, as in what would be the exactly in between. For example, if we had this as a data set, this is the number of attempts students have had for CAT, let's say. So let's say this is our data set. We have 4, 5, 6, 7, 8, 9 students, and somebody has attempted only once, somebody has attempted twice, somebody has attempted thrice, somebody has never attempted. If you have to calculate the average number of attempts, you will sum this up and then divide by 9. So that will be 5 into 10 plus 15 by 9, right? So 15 by 9 or whatever, 1.66. So on an average, a student attempts 1.66. However, if you have to calculate the median, you will choose that number out of this set, which divides the data into half. So this has 9 numbers. So which number would have 4 numbers above it and 4 numbers below it? So 0 and 1 will be below, 3 will be above. So 2 will be the median here, because there isn't a very clear cut median. There are 4, 5 2s here, but still median will be 2. There will be 4 numbers above 2 and there will be 4 numbers below 2. So median is a fairly useful thing many times when averages do not give the right picture. For example, if the distribution is not very neat, as in if it has a very long tail, then median would be useful. What I mean by that is this. Let's assume we are discussing batting average or batting average for 10 players, and most of their averages is 20, 21, 22, 25, 27, so on. So let's say 3, 4, 5, 6, 7. So these 7 players have this, and one player has a batting average of 102. Now he's a superstar, but when you take the average of these 8 numbers, when average of these 8 numbers will be taken, it will come to a fairly high number. It will come to something in the 30s. The average will be something, say 33 or something like that. But that's not a real picture of this team, because there's only one player who has a higher average than 33, and most of them are below 33. So in such distributions where 1 or 2 numbers might be very different from the other group, or like which has a very long tail, median is actually a better metric to get a sense of what is happening. Here the median would again be, let's add one more number. Let's say there was another for with 29. The median will be the player, 4 of whom are above and 4 are below. So 20, if you arrange them in ascending order, this will be 20, 21, 22, 23, 25, 26, 29, and 102, right? So did I miss one? 27 also. So if you choose 25, there are 4 numbers which are below 25, and there are 4 numbers which are above 24. So this becomes the median. Okay. And in such distributions, median is actually a better metric. As you can see here, 25 is a better representation of the average performance of this team than 33 or 34, which would have come if we had taken the batting average. So it's a slightly theoretical distinction, but it's good to know, because then you would be able to predict where mean would be greater than median, where mean would be less than median. So if the distribution has a few very high numbers, then the mean would be greater than median. You can understand why. Just like the way 102 pulled up the mean a lot, it would be the case. In case of the other way is also true. If all numbers were in 20s and there would have been one very small number, say 1, then a mean would have probably been less than the median, because it would have pulled down the overall average, while median would not be that impacted. Median would be the same whether this number is 1 or whether this number is 19. The median will remain at the center number. So it's an important distinction to know. Question do get asked on median at certain points, so you should know. Mode pay question would generally not be asked. It's actually less used statistical term also, but if you want to know, I'll just demonstrate it with here. The number of times 2 happens is 5. The number of times 0 happens is 1. So 0 happens is 1. Number of times 1 happens is 2. The number of times 2 happens is 5. The number of times 3 happens is 1. So the maximum number of times 2 happens. So 2 is your mode. So that's how it is defined. Not very important, so you can let it be also. Just know this much, that this is what is defined as mode. That is that. There is a comment here. How much large must the outlier be compared to other numbers? It's not like it needs to be a. I think you didn't get the exact idea of it. As in, the more the outlier would be, the more important median becomes. Because then, if you have very large outliers, the average starts losing its value, because the average is supposed to reflect what will be the average performance of all of them, not be biased by only 1 or 2 numbers in the data set. So that's how let's look at a few questions. So here we have 7 students appeared for an exam in which the maximum marks were 100. So out of 100, they have to answer. This is the marks scored by the student in the exam were found to be 7 distinct integer value. Arithmetic mean of the marks was 88. So the average was 88, whereas the median of their marks was 92. Okay. What could be the maximum difference between the marks of any 2 students? If you can't see this, I can try and zoom in a bit. I won't be able to zoom in a lot. So between the marks of any 2 students. So let's see. Arithmetic mean of the marks was 88. So the average is 88. Let's mark them L1, L2, L3, L4, L5, L6, L7. So what we know is that the median is 92. So the middle number is 92. There are three numbers above 92 and there are three numbers below 92. Okay. We know the average is 88. Okay. Now we are supposed to find what could be the maximum difference between the marks of any two students. So maximum would be the difference between the student who got the greatest number of marks and the student who got the least number, right? And we know they're all distinct. So we can have three numbers above 92. And since we want to increase the difference, we'll make the numbers as high as possible. So we'll keep L7 at 100 because out of 100 we can get one number as 100. We'll keep L6 as 99 and L5 as 98 because they have to be distinct. So we have got our 4 marks. Now to increase the difference, we want L1 to be as small as possible. But we have a restriction. The average needs to be 88, right? So L2 and L3 have to be below 92 and the average has to be 88. So we'll keep them L2 and L3 as high as possible because that helps us keep L1 low, because L1 plus L2 plus L3 plus 92, 98, 99 and 100 by 7 have to be equal to 88, right? Because the average is 88. So L1 plus L2 plus L3 is fixed. So if we increase L2 plus L3, we will be able to decrease L1. So L2 and L3 can be 91 and 90. And now we need to just find L1, which would keep the average at 88. And here again, you can use the method if you don't need to do all this calculation, if you use the method we discussed just now. So if 88 is the average, we have this as plus 2, this as plus 3, plus 4, plus 10, plus 11 and plus 12. So 21, 31, 33, 37, 40, 42. So the total is 88 plus 42. So L1 can be 88 minus 42. And this number will be how much? 46, right? Yeah, so 46. And so the lowest number can be 46, the highest number will be 100. So the difference will be 100 minus 46 equal to 54. So it's a decent question. You should be able to do this. And hopefully you're able to follow. You don't have any doubts, right? I'm moving forward because there is a lot of content to cover and there is more interesting stuff coming in the second half of this when we move ahead of averages. So if you have some problems, stop me, pull the chain, make a comment or something, and then I'll look at it. Weighted average is generally a easy, you would also have come across this concept earlier. So I'll just quickly cover that also. How do we do? So 10 boys in a class and they have the average weight of 40 kgs, and there are 20 girls and their average weight is 35 kgs. So what is the average weight of all students? Average weight of all students. Again, easy to follow. You just do, if you have to take the average weight, you will need the total weight by all the students. So you know all the students, which is 10 plus 20. And you know what is the total weight, which is 10 into 40 plus 20 into 35. So you'll get total weight at the top and total number of students at the bottom. And that gives actually, and the concept of averages is, weighted average is similar. If you have N1 quantities with average of A1, N2 with average of A2, and 3 quantities with average of A3, then the weighted average will become N1 A1 plus N2 A2 plus N3 A3 and so on, divided by N1 plus N2 plus N3. So this is the average. So basically, if you have averages of different sets and you want to calculate total average, this is a good way to go about it. Let's see, there is a question. I created it fairly quickly. So let's see. There are three types of cars: luxury, hatchback, and sedan, with prices of rupees 30, 15, and 5 lakh respectively. Luxury cars are 10% of the market, while sedans are 30%. What is the price of the average car sold in the market? So you have the average price of these cars, and now you want to know price of the average car sold in the market. So here you'll have to weigh them by their volumes that is there. So luxury car 10% and price is 30 lakh. Sedan 30% and 15 lakh, and hatchback will be remaining, which is 60% and 5 lakh. And then you can take a weighted average, which would be 10% into 30 plus 30% into 15 plus 60% into 5. So basically, because you don't have the volume, you don't need to do the denominator part. As in, if when you add this, this will come up to 100%, which is 1. So that is fine. And this will be the average price of a car being sold. So that is 3 lakh plus 30% of 15, which is 4.5 lakh, plus 60% of 5, which is 2.4 lakh. 3 lakh, sorry. So the average price is 9 plus 13.5 lakh. Again, there is a second part of the question also. What would be the median price? So what would be the median price of a car? Now you need to know what price would divide the entire segment into half. And that would be 5 lakh. Because you can see 60% of the cars are 5 lakh or below, and 40% are above 5 lakh. So at 5 lakh, you can find a car for above which there will be 50% and below which there will be 50%. So median in this case will be 5 lakh. And mode will also be 5 lakh, because the maximum number of cars that are being sold is 5 lakh. So median and mode both are 5 lakh, while the average is 13.5 lakh. And again, you can see how average can be misleading in such cases. You're saying that the average price of a car is 13.5 lakh, although 60% of the cars are sold at just 5 lakh, right? So the average is coming out to be 13.5 lakh, but 60% of your cars are actually being sold at 5 lakhs, which is way below 13.5. So it's just that there are 10% cars which are extremely expensive, and that is pulling the numbers up. So in such cases, you also need to see the median to get a fair idea of what the numbers are doing. It would be 10.5. Did I make a mistake in calculating? Might be. Yeah, sorry. 10.5. Still, it remains true, right? 60% are 5 lakh, which is less than half of your average. So it's not a clear reflection. Calculating average speed, a lot of questions get created. A lot of students first time make a mistake, but once you have seen how to do it, you should not make a mistake. If you have never seen it, then it's excused. It's very easy to make the mistake that most people make, which is okay, I haven't written it properly, but a traveler went from A to B uphill at 40 kilometer per hour and drove back downhill at 60 kilometer per hour. What was his average speed? And doing this is fairly easy for students, which as most of you I think know is incorrect. You cannot take just the arithmetic average of speeds. If you want to go into the details, it will take a bit of time to explain. But if you just want, you can try deriving it using the basic formulas, what it would be. But so the average speed would be the total distance by total time. Right? And total distance would be speed of going into time of going plus speed of coming back into time of coming back by t1 plus t2. Okay. So you cannot do it directly, just average the speeds. You'll need to calculate these numbers and then do the average. Now, there is a standard result which we can derive also for two numbers, or actually, we'll do it when we come to allegation. When we come to allegation, we'll see how we can do average speeds much more easily. Uh, and we'll solve both these questions in a few minutes. So let's hold on to this and I'll come back to it and solve both these questions, because I want to get here first, because this part is important and we have limited time. So we want to cover this, and then we have time speed questions ahead also where we're taking out average speed, and we'll see how to do it. The concept of allegation is this. This is your weighted average, which we saw the formula just a few minutes ago. Weighted average is equal to N1A1 plus N2A2 plus N3A3. So here we are only talking about two quantities. So we will take N1A1, N1 into A1 plus N12 into A2 by N1 plus N2. Now, if you try and make N1 by N2 the subject of this formula, you divide by N2, or you just you can write it as N1 plus N2 into A equal to N1A1 plus N2A2. And then take N1 to one side, take N2 to the other, and you'll get the formula that I have at the bottom. And so for me, you get. So the formula is not very important to remember, because the methodology is important to remember. What it tells you is that if you want to get a certain average, you can very easily calculate what is the ratio in which you want to mix the two of them. For example, the way to do this would be, let's say I am mixing, I have students who are worth 40 kgs and students who are worth 70 kgs. And now I want to create a group whose average weight is 50 kgs. What is the ratio in which I need to mix them? As in, how many people do I need from here? In what ratio do I need people from these two groups? That's the question that's being asked. And what this formula suggests is, if this is A1, this is A2, and this is your final average, which is A, you can just do A minus A2. So we should actually keep it easy. Just keep positive numbers. But it won't hurt even if you have negative numbers, but I'll keep this just to so A minus A2, which is 50 minus 40 or 10, and A1 minus A, 70 minus 50 or 20. So 1 by 2. So N1 by N2 should be 1 by 2. So you should need only one. If you get one player from this side, you should get 2 from the other side. If you get 10 from this side, you should get 20 from the other side. And that's how allegation is used to solve questions. We'll see a lot of questions. But first you need to understand this, and then we have like a long list of questions, and you'll get fairly comfortable with this idea. But let's do it once again, and we'll do it pictorially here. So there are 40 and students worth 40 kgs and students worth 70 kgs, and I want to know in what ratio do I need to get them in a team so that the average weight of my team is 50. The way it is done is, here you just take this minus this, so 70 minus 50 or 20, and on this side you take 50 minus 40 or 10, and this is the ratio in which you need to get these quantities. Here it is students, so here it will be in this ratio, 20 is to 10 or 2 is to 1. So every one student that you get from 70 kg group, you need to get 2 students from the 40 kg group, and that is the basic. Now this can be used to solve a lot of questions. This one is actually what we did just now, so we'll very quickly do it. Average weight of boys in a class is 60, so boys is 60. Average weight of girls is 40, so girls is 40. If the average weight is 48, what is the ratio of, so the average weight here is 48, what is the ratio of boys to girls? So 48 minus 48, 60 minus 48, 12. So the ratio is 8 is to 12 or 2 is to 3. So that's how you get the answer. Now you can very quickly go through all these questions, and some of them a lot of people have difficulty also. Very recently somebody in the group posted a question. Let's see. A sugar sample is 10% impurity and other sample has no impurity. I want to sell a sample with 6% impurity. What is the ratio in which I need to mix these samples? So one side you have 10% impurity, other side you have 0% impurity. You need to mix them to create 6% impurity. 6% minus 0, 6, 10% minus 6, 6, 4. So you need to mix them in the ratio of 3:2. Just ensure that all these metrics are reflecting the same thing. For example, if you are taking 10% impurity here, also take impurity over here, which is 0%. Sometimes students mix up the impurity and purity part, 10% impurity with 100% pure stuff. So then you will get a wrong answer. And then you have 6% here and you get 3:2 as the ratio in which you need to mix these samples. Let's see another one. Now here we have three quantities. Cement was 350 and 200 is mixed with another in the ratio of 1:1:2. If the final mixture is worth 400 per kg, what is the price of the third variety? So let's see first. First you will do for this one. So we have mixed 350 and we have mixed 200, and in the ratio of 1:1, right? So you can use that formula, you can use anyway, but this number will be right in between. If you want to use the formula also, you can use 1 minus 1 would be, if this is x, 350 minus x by x minus 200. Or you can just know that when two quantities are mixed in the same ratio, the average will be just a plus b by 2. So using this, you will get x is equal to 350 plus 200 by 2, or 275. So the first mixture is 275, and since it's 1:1:2, combining these, the ratio becomes 2:2 or 1:1, right? So because we have combined this and we know the average of this is 275. So what is happening finally is you have 275 and the final weight is 400 per kg. We do not know what is the weight of the third one, but we know the ratio is 1:1. So again, you can do the same thing. X minus 400 divided by 400 minus 275 is equal to 1 by 1. Or x is equal to 400 plus 125 equal to 525. Okay. So I hope this is clear how we are doing. These questions are very easy once you know this stuff. If it's not very easy, if you don't know how to go about it, otherwise you can do it almost mentally. You don't need to do anything. A 100 ml flask contains 30% acid solution. What quantity of the solution should be replaced with 12% acid solution so that the resultant solution contains 21% acid? Again, the same thing. You have one flask containing 30% acid solution. You have another flask containing 12% acid solution, and you want to mix them. Basically, you are replacing them, but we want to know what would be the final ratio here, right? So we'll say for this purpose, you can still assume they are being mixed. So you have 30% and 12%. Finally, you want 21%. So 21 minus 12, 9. And here also 21 minus 39. So if you mix them in 1:1 ratio, you would get a solution which contains 21% acid solution. So if you started with 100 ml, how much quantity should you replace and get the 12%? You will get 50 ml out and put in the 12% acid solution of worth 50 ml, right? So you will need to replace 50 ml of 30% with 12%. So it's as simple as that. So you just take 50 ml out and put that. And that we got because we knew that in the final solution, the ratio has to be 1:1 for both of them. If in case of replaced, if the question has asked added, if this had been the question, should be added to the existing, then the answer would have been 100 ml because existing already has 100 ml and we need a ratio of 1:1. So we'll add 100 ml more. So this is how you can solve this question. Same way actually you can do for time, speed, distance also, the average speed concept. We'll discuss this a lot in detail when we do time, speed, distance in a few weeks time. I think it's next week or the week after. But you can use speed and time in the same way. So if I am traveling at 30 km per hour for 3 hours and 40 km per hour for 2 hours, then my average speed can be calculated this way. So same method, 40 minus x by x minus 30 is equal to 3 by 2. And you can solve for x and get the average speed of x. So this was the question we had earlier also, and I didn't cover it there. Uh, but I'm covering it here, and we'll cover it a bit more detail in average uh, uh, when we cover time, speed, distance. So we can hold on to that. I just exposed you here so that you know that this method can be applied to average speed and average calculating average speed. I think we have two more questions. So let's have a look at that. So I'll just check comments once. Nishan travels a distance of 420 kilometers in 6 hours. If we drove on the national highway at a speed of 100 per kilometer per hour and the hilly area at 50 kilometers, what was the ratio of the distance traveled on the highway versus the hilly region? So I again have two speeds, 100 kilometer per hour and 50 kilometer per hour. Okay. But I don't know the time here. But the total time is 6 hours. So I know the average speed. So my average speed was 70 kilometer per hour, right? Because I traveled 420 kilometers in 6 hours. So I traveled some distance at 100, some distance at 50, and my average was 70. So we can again calculate the time here. 70 minus 50, this will be 20, and 70, this will be 30. Or the time is distributed in the ratio 2:3. So if the total time is 6 hours, I spent 2 by 5 into 6, traveling at 100 kilometers per hour, and 3 by 5 into 6, traveling at 50 kilometers per hour. So if you want to calculate the distance, you know distance is equal to speed into time. So for 100 kilometers per hour, my distance would be 100 into 2 by 5 into 6. And if you need to calculate the ratio, you just take the ratio right here. And this will be 50 into 3 by 5 into 6. And you can just divide these to get the answer. 6, 6, 5, 5 cancel. 52, or the ratio should be 4 by 3. Okay. So this is how you can calculate the speed. So you just should remember that this part is speed and this is time. You cannot have distance here. It has to be time. I'll take a pause here. We have been going through some questions. I'll just take a very quick pause in case you have some doubts, questions, and then we'll see other applications also. So these can be, the similar stuff can be applied in profit and loss questions or interest calculation questions. And you should be exposed to this because that eases a lot of effort you might have put in otherwise. So here again, I can earn 3% by investing in FD, 10% by investing in equities. What is the ratio in which I should invest to get an overall interest of 5%? So now though, you don't even need to do all this. You just know what to do, right? So we need to invest in the ratio of 5:2. Because you get 3% from one, 10% from the other. The average needs to be 5%. You can just do it like this. Now, here there is a slight change. So let's look at this question. So there are two samples of coffee. One is Robusta, which has 60% pure Robusta and 40% impurities. And then there's other one, which is Arabica, which is 30% pure Arabica and 70% impurities. Now I'm mixing both of them to create a sample which contains 50% impurities. So what was the ratio in which both were mixed? Now here, this ingredient is different. So you cannot do the same alligation equation for this ingredient, because you cannot do 60, 30, and 50. You might get a wrong answer. What you need is to do it for impurities, right? So one mixture has 40% impurities, the other has 70% impurities. I need a mixture which contains 50% impurities. So what ratio should I divide them in? Should I mix them in? And that will be 40 minus 50 minus 40, 10, 70 minus 50, 20, or 2:1. So you need to mix them in ratio of 2:1. And it's a similar question again. I think you can solve this yourself. I'll just try and zoom on it so that you can see. So there are two types of oils, olive oil and mustard oil in the ratio 11:3. If a third type of oil is prepared in the ratio, so we have the mixture for a third one, and then you have to just find what is the ratio in which they need to be distributed. So now that we have done this, you should be actually be able to mentally do it. There might be some fractional calculations involved, but otherwise there isn't anything very tough in here. So you should be able to do this. Let's do this one again, very similar. So I don't think it needs a lot of effort, but there are two mixtures. One has milk and water in the ratio 1:3. The other has in 2:5. And we are mixing them to get a final one which has 35% milk. So the ratio should be 35:100 or 7:20, right? So just you should ensure that the fractions are correct. So in the starting, one is 1/4 milk, because one is milk, 3 is water, so 1/4 milk. The other is 2/7 milk, and we're mixing it to get 7/20 milk. What ratio do I need to get it in? So you can do it in fractions, subtract and get, or you can just convert it into numbers. So what I'll do is I'll convert it into numbers. I see 20 here, I see 7 here, so I'll just multiply by 140. And when you multiply by 140, I won't write all these steps. I'll quickly do it mentally. But what you'll get is 35 and 40 and 49. We made a mistake. Oh, actually, the question has a mistake, because both of these have less than 35% milk. This is 25% milk, and this is 28% milk, roughly 29% milk. So if you mix these two, you can never get a solution which has 35% milk. So there is a mistake here. So maybe we'll change this for the purpose of this question. We'll change this to 2:3 or 40% milk, and then we'll get a correct one. So we've changed that to 2:3, which means you have 1/4 in one solution, you have 2/5 in another one, and you need 7/20. Or you just multiply it by 20 to get, you multiply all of these by 20, and you get 5, 8, and 7. And so the ratio would be 8 minus 7, 2, and 7 minus 8 minus 7, 1, and 7 minus 5, 2. So 1:2 is the ratio in which I need to mix. Yeah. This one is again very similar. You can do it for profit percentages also. Try doing it yourself. If you have certain problems, let me know and I'll help out. But it should be fairly similar to what we have done previously. Now let's look at a slightly different question. So when you are mixing, you can still do it, but when you're removing, it's a bit tricky to use the same method. So you might have to go back to more traditional methods to solve. At least I think that would be the best approach. So let's look at this question. Not very straightforward, but not very difficult either. In the exam, you should be able to do this. So there's alcohol and vinegar. They evaporate at a constant rate upon boiling, and vinegar operates at 3/5 the rate of alcohol. I'll just move it a bit so that you can see. Sorry. Yeah. So 12 p.m. 10, we have a alcohol and vinegar containing 60% alcohol in order to reduce the. Okay. So what is happening here is you have an existing solution which has alcohol is to vinegar in the ratio of 60 is to 40. Now we are boiling it till alcohol becomes 40 and vinegar becomes 60. So we want to go from here to here. So, and what she does is she boils it for 10 minutes and in between, so at 10 minute stage, this is the state of the solution, 50 is to 50. Like both are equal. And now what we are also told is that vinegar would evaporate at 3/5 the rate of alcohol, which makes sense. So if you want to boil and reduce the concentration of alcohol and increase the concentration of vinegar, vinegar has to boil at a slower rate than alcohol, right? So we start at 60 and 40. So let's see how we'll do it. In these questions, when you're removing, it's not possible to apply the previous method. What you can do is just assume, and in this case, you can even assume a volume because nothing has been. So I'll just assume here that initially there was 100 liters of the solution. So there was 60 liters of alcohol and 40 liters of vinegar. Now we are evaporating it, and in 10 minutes, it had come down to 50-50. So 60 minutes, let's say y liters was evaporated for alcohol. For vinegar, it would be 3/5 y, right? Because it evaporates at 3/5 the rate of alcohol. So vinegar will be minus 3/5 y. And this becomes 1/1. So using this, you can calculate vinegar, y. So, and you calculate y becomes 20 into 5/2 or 50. So we are not actually interested in the value of y. What we are interested in is in how much of y. So it's what this indicates is that you would lose 50 liters of alcohol in 10 minutes, which was 12:10 to 12:50 20. So what we now need to go to is what would be the amount, as in how many times y do we need to move? 40 minus k. So now we are saying will move k times y to get the ratio which we desire, which is 4/6 or 2/3. So now you need to solve for this. You know y is 50, and using that we'll solve this. So let's just do it. Y is 30, 40 minus 50k. And this will be 2 into 40 minus y50, 30k. And again, you can solve for 150 minus 60, 90k equal to 180 minus 80, 100, or k equal to 10/9. So what it says is you need to do 10/9 of the time done previously. So she did it for 10 minutes. So what she actually needs to do is 10/9 into 10 minutes, or 100/9 minutes, or 11 1/9 minutes. So if she boils for 11 1/9, she will get the concentration of alcohol that she needs. She started at 12:10, did it for 12:20, so she had already done 10 minutes. So she needs to do 1/9 minutes more. So 11:29 1/9, she can stop. How did we do this? Let's go through this again because I did a lot of stuff, so you might have missed some of it. We have started boiling. the ratio was 60:40. So we just assumed it's 100 liter. It won't change anything for us. So we started boiling. We assumed the rate of evaporation for alcohol was Y in the first 10 minutes. It evaporated Y in the first 10 minutes, which meant vinegar would have gone by 3/5 Y, and the ratio would be 1:1 after 10 minutes, right? Because we know it was 50/50. So using that, we calculated Y, and Y came out to be 50. Now Y as a number is of no importance to us, but we want to know how many times Y do we need to do to get to 2/3, which was our desired ratio. So we put KY. K was the number of times we need to do Y, and we solved that equation to get K equal to 10/9. So we know that now we need to do Y 10/9 times. Y happened in 10 minutes. So the total amount needed is 10/9 into 10, or 100/9, which is 11/1/9 minutes. So the total time we need to boil is 11/1/9 minutes. We have already boiled for 10 minutes. So we need to boil additionally for only 1/1/9 minutes. This is again very similar question. If you have understood the previous one, you should be able to do this one on your own. Try doing it and let me know if you face issues. This would be a good practice. Exactly similar to previous question. Not much has changed except for the way of writing it. So if you have understood the previous one, you should be able to do this one. This is the final concept that we need to cover today. When you remove it, so we have, what the question is saying is, I have a beaker which has 100 liters of milk. Now I remove 5 liters and put 5 liters of water in it. Right? So I've removed milk, I have put water in it. So how much is left? Now it is 95 liters of milk and 5 liters of water. Right? Now if I do the same thing again, out of this bucket, if I remove 5 liters and put 5 liters water back in, when I remove, I won't be removing milk, right? I will remove 5 liters of the solution. So I'll get 95% milk, but I also get 5% water. So how much milk would remain the third time? It won't be 90 liters. It would be slightly more than 90 liters. What would be left is, out of the 95 liters, we removed 5%, so 0.95. That much milk would remain, which is slightly more than 90, right? And again, so it's the same way the water would have increased. Water would be more than, would be less than 10 liters. It would be 5 liters that we have put in plus some more liter water which is remaining from previous. And uska ek formula aata hai, just the way we derived it, actually that's how it's derived. So if you remove and replace once, I'll do, like, if you remove 5%, I started with 100 liters, I'll remove 1 minus 5%, so I'm left with 95% pure. But you do it again and I'm left with 95% again, so 1 minus 5%. And if you remove and replace again, I'll still be left with, I'll keep multiplying by 0.95 to get to 100, 1 minus 5% to the power n. So if I am removing k percentage n times and replacing with something else, the amount of pure stuff you will have remain in terms of percentage, whatever was starting amount, 1 minus k% raised to the power n. And using this, you can calculate. Saurav is asking, could you please explain again which one, the previous question or this question, Saurav? I saw your comment right now. This one we'll discuss and we'll do it again. If you had the previous problem with the previous question, try watching the video again later on. If you don't understand, then message and ask and I'll explain again. Let's see what we are doing here. The way what is happening in this question is, you have a solution which has 100 liters of liquid, of pure liquid, let's say milk, and now you take out 5 liters of this and replace it with water. So what remains is 95 liters of milk and 5 liters of water. But the second time you do the same thing, plus 5 liters of water, but when you do minus 5 liters, it's not only milk you remove milk plus water, because now it already has some water in it. So here you cannot say that this will have 90 liters of milk and 10 liters of water. This is incorrect. right? How much milk would be here? That would be 95 into 0.95, because you have removed 95%, as in you have removed 5% of the stuff, and that would 5% would be washed from here also. So if we wanted to calculate, and if we keep repeating the same thing, the amount of milk will keep reducing this way, into 0.95, into 0.95 again, and so on. If you do it k times, eventually you would have the amount of milk that you would have is, if you started with 100.95 to the power of k. So that gives us the formula when you are replacing moving thing, taking liquid out and replacing. The formula again, you can take the starting amount and then 1 minus k percent, if you're replacing k percent, to the power of n being the number of times you do that activity. So here it's saying it is repeated 3 times. How much is milk left after the third time? So here you will do 100 liters we started with, and you did 1 minus 5% to the power 3, or 100.95 to the power 3. And then the question will have options, etc. You can see which one matches the option. So this is how you solve it. Let's look at this question. From a can of petrol, 15 liters of petrol is removed and replaced with impurities. Same process is repeated 3 times, and eventually the ratio of petrol and impurities came down to 343 is to 169. How much impurity was there initially? Okay. So so what you're doing here is you have a can of petrol, you remove 15 liters and you put back 15 liters of impurities, and then you repeat that step thrice. And after that, after you have done it 3 times, your ratio of petrol to impurity is 343 by 169. Okay. Or your ratio of, so this is petrol to impurities. If you just wanted how much is petrol in there, that's 343 by 343 plus 169, right? The ratio, and that you can take out as 343 by 34, 500, 512. Okay. And if we started with say, we started with pure petrol, right? So 343 by 512, which is the final purity, is 1 minus x percent to the power cube, if you are removing x percent every time. And from here you can calculate value of x. So just let's do it right now. This is 7 by 8 cube. So you know 1 minus x percent is equal to 7 by 8, or x percent is equal to 1 by 8. So each time that I am removing the volume that I am removing, which is 15 liters, is basically x percentage of total. So 12.5% of total, or 1 by 8 of total, is equal to 15 liters. So the total is equal to 15 into 8, or 120 liters. Okay. So I'll again go over this one. So we have a can, we remove 15 liters and replace it with impurities, and we do it 3 times. Eventually we are left with a ratio of 343 of petrol and 169 impurities. So you can adjust that to, so if petrol to impurity is 343 by 169, petrol to total will be petrol by petrol plus impurity. So we did that. So we did 343 plus 169. And that led us to 343 by 512 as the final ratio. Now final ratio, which is 343 by 512, can be got by 100% pure petrol, which we started, and we are removing x percent every time 3 times. So we try and calculate x, and using whatever, it's an easy calculation. If you notice that this is 7 by 8 cube, we get x percentage is 1 by 8, or 12.5% of the total. So 12.5% of total is being removed and replaced every time. And we know that amount is equal to 15 liters. So we need to know the total. So total will be 15 into it, or 120 liters. Let's look at this question. Very similar, but still slightly different. So there is a jar which has 120 ounces of milk. Okay. First day, X ounce of milk is replaced with water. So we take X out and replace with water. And the second day, whatever we get, which is 120 minus X milk and X water, we again take 120 minus X out and we replace with 120 minus X of water. Find the maximum concentration of milk in the jar at the end of day 2. So how much milk would be there at the end of day 2? So we started with 120. Okay. How much milk would remain after, or let's start with purity itself, that way it would be easier. So you have 100% pure, right? After the first change, what would be the percentage purity of milk? So we have 1 minus, we have removed X and replaced it with water. So 1 minus X by 100 would remain milk. Sorry, X is in wo, so we need to get the percentage. So 1 minus X by 120, that's the percentage, would be the percentage purity. And then you need to do it a second time, and the second time it's not X. So earlier what we were doing were, because each time it was replacing the same number, we were doing it like this, and hence we could do the power. But this time, the second time, the replacement is not X, it's 120 minus X. So we'll put that also, 1 minus 120 minus X by 120. So that would be the purity of concentration of milk after those two replacements. And so you can simplify this. So this is 120 minus X by 120 into 120 minus 120 plus X by 120. So the only variable here is 120 minus X into X. So X into 120 minus X. And you need to find the maximum value of this so that the concentration can be maximized. And if you can use AM greater than GM, you can use differentiation if you know that. But either way, you know that at X equal to 60, this quantity will be maximum. So for X equal to 60, your concentration would be 100% into 120 minus 60, or 1 by 2 into 60 by 120, again 1 by 2, or 25%. Okay. So I'll just again re-explain this because we went through it fairly quickly. 120 ounces of milk we start with, or 100% pure milk. We put in X, we remove X amount of milk and put in X amount of water. And then from that solution, we again remove 120 minus X amount of milk and put in 120 minus X amount of water. So we have done it twice, but not the same amount both times. So we adapt the same formula. We had 100% earlier. Then we removed X by 120%. So 1 minus X by 120. And then we removed 120 minus X by 120. So 1 minus 120 minus X by 120. And that led us to 100%, 120 minus X by 120 and X by 120. So since the question asks what is the highest concentration of milk possible, we needed to maximize this term because everything else is fixed, X into 120 minus X, and that will be maximum when X is equal to 60. So putting X is equal to 60, we got the concentration, which was 25%. Okay. So this was about alligation and mixtures, I think, and we touched a bit on averages also. I hope you are able to now find this stuff easy and you are able to solve these questions. A lot of students who have not studied this suffer a bit, and it's slightly new also, as most of us have not been exposed to such things in school level, or have been exposed to much more difficult ways to solve these questions. So I thought it was worthwhile spending some time on it. Next class we'll do ratio and proportion. I wanted to cover it in this session, but I thought it would be too much. So we'll do ratio and proportion in the next class. But if you have any doubts, any questions, let me know. Shreyans is saying we didn't start with 100% pure. We need to find initial impurity. Which question? The milk question. It says a jar of capacity 120 is filled with milk to the brim. So if you're talking about this one, it should not be that thing. The both questions we are starting with pure Shreyans. Comment again if you have something, if you notice something differently. But I think we start here with pure milk itself. So, but otherwise, have a look. We didn't cover average speed a lot in detail. We will do it when we do time, speed, and distance. So don't worry about that. But other stuff you should practice. You should become very comfortable. You should be able to adapt the formulas also where needed, and then hopefully you won't be scared in the examination when you face such questions, or you will also be able to see where you can use this method even if it's not directly applicable, for example in profit and loss questions or in interest calculation questions or in average speed questions. So that is there. I'm sure the question is how many impurity was there initially? Sorry, I didn't notice this, Shreyas. So I'll do what Saurav has asked first. I'll just go through this question quickly and then we'll go ahead and have a look at the previous one also. So this question, Saurav, we have already done twice. So I'll again explain it, but I'll try and do it slightly differently. So you start with a 120-liter bucket which is full of milk, pure milk, and then you do two substitutions. First, you remove X liters of milk and put in X liters of water, and then you again, whatever is the solution you get, you remove 120 minus X liters of that solution and put in 120 minus X liters of water. Okay. So we need to find what is the maximum possible concentration of milk. So we need to find for what value of X will we have maximum amount of milk remaining after these two situations. So initially it was 100% pure. When we removed X and replaced it with water, the purity would be 100 into 1 minus X by 120. So this part. And from this solution, we remove 120 minus X by 120. So the remaining purity will be 1 minus 120 minus X by 120. And then you simplify this stuff. You are left with 100% into 120 minus X by 120 into X by 120. Now you need to find the maximum possible concentration of milk. So to find the maximum possible concentration, you need to find the maximum value of this. Everything else is same except for X into 120 minus X. So we will try and maximize this number. To maximize this number, you get X is equal to 60. And for X is equal to 60, when you substitute, you get 25%. Okay. So this is how it is. Spend some time, try putting pen to paper, and you should be able to get it. Coming back to the previous question, where it might be that I might have made a mistake, right? From a can of petrol, 15 liters of petrol is removed and replaced with impurity. Same process is repeated 3 times. Eventually, the ratio is this. Okay, how much impurity was there initially? So eventually this is this. Let's say we have the initial impurity is, let me think how we'll do it, K percent. So we have a K percent pure thing initially, and then we do 1 minus X percent to the power 3. And I'll need to check if I'm missing something here, because what else could we be missing here? I'll need to check if there's a typo, or the other way might be there is a number system kind of a thing here that for only a certain number this product is possible, because otherwise I do not see any other way we could get this number. If the initially also it's impure and then we remove 15 liters and keep replacing. We don't have total volume, right? We only have 15 liters of petrol is removed and replaced. We don't have the volume of the can. It's fine. I'll look into it. I am not able to think of the way right now, but my sense is if the question has been typed correctly, there might be a number system thing over here that this number is possible only for a certain thing or certain kind of values. No, we cannot assume 100 because it is specified that 15 liters of petrol is removed. So in this question, you cannot assume 100. Where is 12.5%? No, no, no. So what I'm saying is ki, you cannot do this if the initial part is impure. This part is only possible if you have already assumed that initially it was 100% true. Otherwise, your equation, if the initial part is not 100% pure, will be this: 343 by 512 is equal to k percentage purity, which was there initially, 1 minus x percent cube. So now you have two unknowns. One is this x and one is k. X you can substitute by, yeah, so, and so there is only one equation. So it's not that straightforward. Either there is something, or my guess is this would be how much petrol. This might be just be a typo. Actually, that's much more easily believable. So I'll go and check it and I'll let you know. I'll just comment here. But my sense is this must be how much petrol. No, Saurabh, what you are saying won't work. Your equation is wrong. So as I said, uh, one that you're writing initially is for 100%, so it's not 100% pure. 15 by x needs to be the total volume, uh, not just the initial purity. So you can assume the total initial total volume as x, but still it won't. So let it be. I think the question is petrol, and that's the most easiest explanation also. I don't think it can be solved with the other one unless I have missed something. So, but I'll again still I'll check and I'll get back to you in case I have missed something. But the mistakes that you guys are making, it's telling me that you still do not have the very strong grip on the concept. So please spend some time working through these questions. Put pen to paper, attempt them twice or thrice, and you will get to know why what number is used where and why is it so that you won't make such mistakes. Okay. I'll close it over here. We'll have another session on other related topics. But if you have any feedback, any suggestions to improve, and so on, please feel free to let us know. Okay. Thank you.